All right, so this is 2.1 homework on the natural numbers. And this first problem, what we want to do is we want to draw a picture of the following. And so the idea is to try to attach a natural number like 1, 2, 3, 4, 5, and so on to a geometric concept. And so we want to show 15 is a triangular number. So the way we do this is we try to take 15 dots and create a triangle out of it. So we write 1, and there's 2 dots, and then we draw 3 dots, and then we draw 4 dots. Right, so altogether we've drawn 10 dots, and then we draw 5 more. Right, to get 15 dots total, and you see we have a triangle. So that's why 15 is called a triangular number. And 25, of course, is called a square number, and we can represent this geometrically by taking 25 dots and creating a square. And so here I have 5 dots, and I reproduce these 5 times. And so there's 3 rows, 4 rows, and 5 rows. And if it was really exact, I kind of went up there, but you see you get a square out. So that's why 25 is called a square number. And then finally, we want to do 27 as a cube number. Now this one's a lot harder to do because it's 3-dimensional. And so the first thing I might do is I might construct my square. So I'll draw a little square here. Oh, I should say a cube, right? It's a cube, right? It's 3-dimensional, so I'll make my little cube, not a square. Right, square is 2-dimensional, cube's 3-dimensional. And I'll draw little dotted lines to kind of indicate, it goes in the back. Little dotted lines down. And then what I want to do is I want to put my dots on this square, and I need to do 27 of them. So the idea is you put 3, and 3, and 3. So this is the front of the square, and then you're going to put another sort of sheet of 9 dots. Let's use a different color for the middle. So maybe I'll use, let's use a sort of a light brown here. And so then I have another sheet of dots behind it. So 1, 2, 3, right, 1, 2, 3, 1, 2, 3. Right, so that's like the middle sheet of 9 dots, and then I have one more behind that. And so again, let's pick a slightly lighter color than that one, maybe this peachy color here. Right, so I take that peachy color, and I make another sheet of 9 dots. 1, 2, 3, 1, 2 on the back face there. 2, 3, 1, 2, 3. All right, so basically you have, if you want 9 columns of dots, right? Here's 9 sheets of 3 sheets of 9 dots each, right? So 9 dots, 9 dots, 9 dots for a total of 27 dots, and it's represented as a cube, right? They align up in a cube shape. Okay, on the next one, let's look at this here. What we want to do? Okay, we want to use the factorization tree and find the prime factorization of each number. Now 50 is relatively simple, okay, to factor, right? So you can take 50 and let's just do it like this, right? So 50 is 2 times 25, and then 5, of course, is 5 times 5. Right, so I can write 50 as 50 is equal to 2 times 5 times 5, so 5 squared. 475 is a little bit harder, and since I'm not allowed to use my calculator, I have to think about, how am I going to find 2 divisors. And maybe really easy when I see 475, I know 25 goes into this, and I think about this as $475, and how many times does 25 go in there? Well, it goes into 100 4 times, so I have 4, 4, 4, 4, so 16 plus 3 more, right? So it should be 19. Right, so what I have here is 25 times 19, and then 25 can be factored, 5 and 5, and then of course 19 can't be factored anymore, right? 19 turns out to be prime. You can look at this and say, is 2 go into it? No. 3, 4, 5, 6, 7, 8, 9, 10, then you're done, right? So no other numbers go into this, so it's a prime. And so 475 can be written as 5 squared, right? 5 times 5 times 19. So 5 squared times 19. And so this is how you use a factorization tree to find the prime factorization of a number. On number 3, what we want to do is we want to find the GCD, which stands for the greatest common divisor, and the LCM, which stands for the least common multiple of each pair of numbers. And so to do this, we make the factorization trees. So like for 12, this would be like 2 times 6, and this would be 2 times 3. And for 24, we get 2 times 12. 12 again is 2 times 6, and 6 is 2 times 3. And we end at their prime factors, right? These end leaves, or they're sometimes referred to, they're prime, so you can't go any further. And if you want to find the GCD of 2 numbers, which means you want to find the largest common divisor, right? The greatest common divisor, the largest number that goes into both of them. All you need to do is circle what they have in common. So do they have a 2 in common? Yeah, they got a 2 in common. Do they have another 2 in common? Yep, they have another 2 in common, so you circle that. And do they have a 3 in common? Yep, they have a 3 in common. And then you just multiply what they have in common together. So 2 times 2 times 3. So this is equal to 2 times 2 times 3. And of course, 2 times 2 is 4, times 3 is 12. Which is kind of an obvious answer, right? What's the greatest common divisor? Well, 12 goes into 24, and 12 goes into 12. So it must be 12. For the least common multiple now, and again, you really don't have to do a lot of work on this one if you don't want to, because you say, oh, least common multiple. Well, 12 goes into 24. So 24 is a multiple of 12, and certainly 24 is a multiple of 24. So the least common should be 24. But if you didn't know that, you can say, okay, what is one common multiple, the most obvious one? Well, you just take the 2 numbers and multiply them together. That's certainly always going to be a common multiple of the 2 numbers if you just multiply them together. But the problem is they might have other divisors in common. So what we do is we divide out by the greatest common divisor, and that'll give us back our answer. So the 12s cancel here, and I just get back 24. Right, so the greatest common divisor is 12. The least common multiple is 24. The next one, 70 and 90. So again, we do these little factorization trees, and they'll help us find the greatest common divisor. And so when I do this one, I think, okay, well, I can do 2s, I guess. So 2 times 35. This is 5 times 7. So it's a factorization tree of 70. For 90, I guess I can start with 2s again. So 2 times 45. 5 times 9 is 45, and 9 is 3 times 3. All right, so the GCD of 70 and 90 is just equal to, well, I circle what they have in common. They have a 2 in common, yep, so I'll circle it. Do they have a 5 in common? Yep, so I'll circle it. Do they have a 7 in common? Nope, and I can stop. Right, there's no other numbers to look over here to see if they have anything in common. And so my answer is just 2 times 5. Right, so 2 times 5, which equals 10. So 10 is the largest number that will go into 70 and 90. The next thing I want to find is the least common multiple, LCM, of 70 and 90. And the idea is real simple. It's just going to be equal to, well, one common multiple would be 70 times 90. So it's certainly a common multiple. The problem is that it might not be the least. To make it the least, I'm going to divide out by the greatest common divisor, the divisor that the largest one they have in common. And so I divide out by 10. And so this is equal to, and you can do this a number of ways, so I can just cancel the 70 and the 10. So 70 divided by 10 is 7, right, times 90. And so this is going to equal, this is going to be, and I can do this on the side. Remember, I don't have a calculator to do these, so I have to do them by hand. Right, so I do it long ways here, 0, and then 9 times 7 is 63. So this is 630 is my answer.